The first question in this video is an example of how to calculate conditional probabilities. So let's read the question first. The study of the US clinical population found 22.5% diagnosed with mental disorder, 13.5% with alcohol-related disorder, and 5% with both disorders. So let's write that down in mathematical notation first. Probability of mental disorder is 0.225. Probability of alcohol-related disorder, which is going to call it A, is 0.135, and probability of both, which means M and A, is 0.05. So we've got all the probabilities listed from the question. Now let's read the first part. It says, what is the probability that, so P of, that someone from the clinical population is diagnosed with mental disorder, so P of M, knowing that, so that's the symbol for knowing that or given that, the person is diagnosed with an alcohol-related disorder. So it's probability of M given A. So the formula for conditional is probability of M and A divided by probability of A. So where that comes from is probability of alcohol-related disorder and mental disorder is equal to probability of the first, which is probability of alcohol-related disorder, times probability of the second, it's times because of and, given that, since the two are not independent of each other, given that A happened. And now we just solve for probability of M given A by dividing both sides with probability of A. So that's where the formula comes from. So probability of M given A is probability of both divided by probability of A. Whatever comes second is in the denominator. So once we've figured out what we need to calculate, the formula is very straightforward. So probability of both is 0.05 divided by probability of the first, which is alcohol-related disorder, is 0.135, and just use your calculator to figure out the final answer. Now here's another example of calculating the conditional probability. What is the probability that someone from the clinical population is diagnosed with alcohol-related disorder, so diagnosed with A, knowing that, so given that, the person is also diagnosed with mental disorder. So what is probability of A given M? The pattern is very similar to the one we did above. So probability of A given M is equal to probability of both, so that is probability of A and M, divided by probability of the second, so which is probability of M. Now we know the probabilities, we listed it right at the beginning of the problem. Probability of both is 0.05, and that's what we plug in. Probability of mental disorder is 0.225, and then the rest is done by the calculator. Now this is the same question from the previous slide. Probability that someone has mental disorder is 0.225, probability that they have the alcohol-related disorder 0.135, and the probability that they have both is 0.05. So we first use a Venn diagram to solve this problem. So let's just draw the Venn diagram. So probability of M is 0.225, probability of alcohol-related disorder is 0.135, but the reason that we subtract the 0.05 is because the probability that a person has both is 0.05. So in this region of the Venn diagram where there is an overlap, that's the probability of both happening together, because that's the overlapping region. The number that fits into this portion of the Venn diagram is the probability that someone has only mental disorder, which means we have to subtract the probability that they have both. So probability of 0.225 says that it's the probability of having having mental disorder. We subtract the overlap, which is the probability of having both, and then that gives us the probability that someone has mental disorder only. So this is M, not just M, but the word only following that. So if I say what's the probability of M in general, then you have to include the entire circle. So that would be 0.175 plus 0.05, which is really equal to 0.225. But if I say what's the probability of mental disorder only, then you look at this number, which takes the probability of mental disorder and subtracts the overlapping probability from it. So that would be the probability that a randomly chosen person from the US clinical population has only mental disorder. We do the same thing with the alcohol related disorder. So if I say what's the probability of having alcohol related disorder in general, that would be the entire circle A. And if I say what's the probability that a person has only alcohol related disorder, so if the word is only, then that would be probability of alcohol related disorder minus the overlap, and that gives us the probability of alcohol related disorder, and the word following that is only. Now if I say what's the probability of alcohol related disorder in general, it would be everything inside the green circle. So that would be 0.05 plus the 0.085, which is equal to 0.135. If I add these two, obviously I'm going to get back 0.135. So now this completes the calculations mostly. We just have to worry about what's sitting outside the two circles. So let's draw a big rectangle outside. So there are people who sit outside the circles, and if a person is sitting right here, for example, then it is a person who does not have mental disorder and does not have alcohol related disorder. So this person is free of mental disorder or alcohol related disorder. Another way of saying that would be this person has neither alcohol related disorder nor mental disorder. So that would be 1 minus, we add all the numbers, that is 0.175, 0.05, 0.085, and that would be subtracting 0.31, and that gives 0.69. So that is the number that is outside, 0.69. So it's 1 minus. So if we add all the numbers, 0.175, 0.05, 0.085, and 0.69, the total of all the numbers in the black circles has to equal 1, because that is the total probability of the sample space. So the first question says, what percent of the US clinical population is diagnosed with mental disorder but not alcohol-related disorder? Which means, what percent of the US clinical population has mental disorder only? And we've done the calculations. It is 0.225 minus 0.05, which is the overlap, which is equal to 0.175. Now what percent has mental disorder or alcohol related disorder? So it's 1 or mental M or, so probability of M or alcohol related disorder. Okay, but the important thing to remember is when the statement says this or that, it also includes the overlap, which is 0.05. So the probability of mental disorder or alcohol related disorder is the sum of 0.175, 0.05, and 0.085. So we've made sure that the overlap was not counted twice, because we figured out the probability of mental disorder only, alcohol disorder only, and then of course the probability of both, and that would give us the probability of mental disorder or alcohol related disorder. Now the next question is, what percent has neither a mental disorder nor an alcohol related disorder? So basically that's the calculation we did here. This person sitting outside of the two circles has neither a mental disorder nor an alcohol related disorder. So we add up all the numbers within the circles, which gives us 0.31, and that's what we subtract from 1 to get 0.69. So 0.69 is the probability of a person having neither of the two problems, which is mental disorder and alcohol related disorder. Now, in the first part of the question, we found the probability of mental disorder or alcohol related disorder, so M or A. And we used a Venn diagram to answer that question. Now, is it possible to solve this problem without the Venn diagram? So let's see. Let's first list all the probabilities. So probability of mental disorder is 0.225, that was given to us. Probability of alcohol related disorder is 0.135, that was given to us. And the probability of both, which was 0.05, was also given to us. Now the question is, we have to figure out probability of M or A. The word OR goes with the addition rule, but what kind of addition rule is used depends on whether the two events M and A are disjoint or not disjoint. Now, disjointness, when we say that A and B are disjoint, what it means is that the two events cannot happen together. But in this case, notice that mental disorder and alcohol disorder can happen at the same time to the same person, because we know that from the fact that probability of mental disorder and alcohol related disorder is 0.05. If it was 0, then we would say it's disjoint, but since it is not 0, the two events M and A are not disjoint. And from the chart, this is the formula that applies to probability of M or A when M and A are not disjoint. So probability of M 0.225 given, plus probability of A 0.135 that was given, minus probability of both, which was also given, and that's equal to 0.31. Notice that it's the exact same answer that we got by using the Venn diagram.